Hello. These are a couple of practice problems from section 4.2 that I'd like to share how to work with. I'm hoping that you're looking at the screen here. I wish that I could print something out so that we could just do a couple problems here and there, but if this is one of the problems that's giving you trouble, then you can go ahead and watch. And I actually am going to do 1, 2, 4, and then 3. So first of all, number 1, what we're doing is we're rewriting 36 to the x equals 6. So all that we have to do is we're gonna rewrite it as a logarithm. So it's going to be log. And the thing about logarithms is that all they are is another way of writing an exponent. So the exponent in this problem is x, so it's going to equal x. Well, what's attached to the x is the 36. And that is the base. So this is going to be 36. You drop it down a little bit. It's a subscript. And there's only one other piece to this problem, and that is the 6. So this is log base 36 of 6 equals x. On problem number 2, we're going the other direction. We're going to turn that logarithm back into an exponential. And again, a logarithm is another way of writing an exponent, so the 4 is the exponent. Some people like this, some people don't, but I'm going to start with 5 and kind of make a curly Q. And what this converts to then is it converts to 5. We started with the 5, that's what we circled first. Again, what the logarithm equals is the exponent, and then we finish with the 625. Finally, on problem number 4, same idea as problem number 2, but the one thing that you need to know is, and I didn't write the problem very well, so I'm going to write it just a little bit better, is it's log of x equals 4. But since there's no base, there's no subscript written on an log, it's 10. And I don't know if you can see, I wrote it in purple. But once we know that, again, a logarithm is another way of writing an exponent. Coincidence that the exponent is a 4 again. But if we start with the 10 and we kind of curly Q around, then what we're going to get is we're going to get 10 to the 4 equals x. Again, these are just practice problems from section 4.2. I posted an 8-minute video that kind of goes through these ideas. I recommend that you watch it. But this last one, problem number 3, is going to apply the properties here, and I'm going to try to separate this out a little bit. And the first thing that we're going to deal with is we're going to deal with this 3. And we're going to make that an exponent. So this is going to be log base 12 of 2 cubed. It is a logarithmic property. We can do the same thing with the 1/3. It's going to be log base 12 of 8 to the 1/3. And then we have minus log base 12 of 4. Well, in that first one, we can simplify a little bit, and we get log base 12 of 8, 2 cubed. On the next one, type it into Desmos, type it into your calculator. 8 to the 1/3 power is 2. And then we have minus log base 12 of 4. Notice that these are all log base 12s, and that's important. We can't use logarithmic properties without having them have the same base. But now what I'm looking at is I'm looking at this plus here. And this plus is tells us, based on the logarithmic properties, that we can rewrite this expression as 8 times 2. Notice that I only wrote the logarithm once, the word logarithm. We still have the minus log base 12 of 4. If we simplify that a little bit, we get log base 12 of 16, which is what 8 times 2 is. minus log base 12 of 4. And then we're going to use the last property. We have a minus in between these two logarithms. And minus says that we can divide. And as I pull that up a little bit so you can see it a little bit better, log base 12 of 16 divided by 4. Well, 16 divided by 4 is 4.